Hi. So I'm going through this book's code, which is PyTorch for deep learning, creating and deploying deep learning applications. They have a wonderful code repository. And Pointer is I think, the primary author. The rest of the folks are uh, contributing. There are a lot of translations. I couldn't understand what language this is, but there are translations which are there. So this is where all of it starts. So there's a download.py, and basically chapter 2. Chapter 2 is where I've started, and pretty easy to understand. There is a Python notebook with comments and code, download.py, and there is a images.csv. So there's a CSV file in which there is a list of images which are coming down, which can be downloaded rather from various sites, most of them from Flickr. So yeah, so then I tried to figure out how to probably create my own CSV file and get uh, images down from Flickr. So there's lots of code which is available, uh, many different. I found this one to be quite interesting. How to scrap Flickr, but I'll get into all of that later on. So what I've done is from there, from here I've downloaded these three files. I've got them over here, and I just call it uh, yeah, chapter 2 this thing, and download.py. And yeah, so how I have this organized is, right now I just created this mm, one file. I just call it so I given it that, that I have from this particular source and from their repo, and this was their download.py. And what this basically does is, so once you start running executing this file, it will create two classes. So basically these two classes, cat and fish, are being read from that CSV file. So that CSV file, which is this images.csv, has got two classes over there, and set type. So this is basically three directories will get created: test, train, and validation. And what will happen is, you'll get these further two directories created. We'll ignore this airplane for now. I'll explain what this is later. So cat and fish, and within cat and fish, first the train directory will get populated with two subdirectories, cat and fish, and you'll get images downloading into it. So this is how you'll get errors in case a image is not found. It'll keep giving you these errors that, this particular image wasn't found. Rest of them it'll download. It'll download, I think, about 1,000 images to begin with in train, and similarly in test and validation. So yeah, this is one way of doing things. I wanted to run this code on my own images. So own images in the sense, images the uh, from the Caltech dataset. So Caltech 101. So this I've been playing with earlier also. So it's got wonderful images of airplanes that I wanted to train on, and obviously you can pick up any of these other classes to be non-airplanes, right? So I just picked the faces, and I just call it non-airplane. So all the faces that are here obviously are very, very different from the airplane photographs. So it helps to kind of have a negative class over there. So this is what I've done. So in train I have airplane and not not plane. Yeah. So not plane is basically just the faces, and airplanes is the and yeah, within airplanes I didn't necessarily have to have this, but then I was trying to do something else, so that's okay. So I have a subdirectory which again says airplane, which is okay. Okay. So this is code from uh, their chapter 2 IPython Jupyter notebook, and I've gone through this pretty self-explanatory, most of it. And what I didn't really understand or I had any doubts, I went and Googled it, and of course, I put in some code from here earlier, what I was doing earlier, the official uh, Penfudan pedestrians this thing dataset. From this code, I put in few things over here. So, and wherever I couldn't understand something, I've just gone ahead and Googled and tried to see what's happening. Yeah, so that's how I've kind of gone through their code repository and understood what's happening. And okay, so now time for a quick demo. So these are the imports. Then setting up data loaders. This is from their code. I've just kind of copied this comment. Um, so torch vision datasets image folder to quickly set up some data loaders of downloaded cat and fish images. So yeah, cat and fish, these images are here, but I have airplane and not plane, so yeah, this is okay. So just a very simple function to check if it's an image and it's been opened by pill, and if that is the case, then just return true. That's all. Set up the transforms. So over here, the size is 64 by 64. Usually what will happen over here, like if you'll see, the size will be 264 into 264. So that's their recommended for, at least for ResNet. Uh, but this is custom code. So yeah, 64 by 64. So small size. Transforms to tensor. This 2 tensor and pill 2 tensor, this gave me a lot of issues because earlier when I was running their code, uh, this pill 2 tensor and this 2 tensor, I've played around with it earlier, and resize I've done to 256 over here, and then done a center crop and all those things, but that's recommended in this one. So over here it's not recommended, so not done any of that. And then normalize being done. I'm not really sure why these numbers, but yeah, it's in their code and they're doing it. So normalize using ImageNet mean, and so something recommended for the ImageNet images, it seems. That's okay. So I've just gone ahead with that. Then there, this thing comment only our first model, SimpleNet. SimpleNet is a very simple combination, three linear layers and ReLU activation between them. Okay, don't do a softmax in the forward and all this. Okay, fine. So this is how the class is defined, and then from subclassing from nn dot module, and I have not changed anything over here. I have not even gone into details of this, but I can understand that this is a fully connected layer one, layer two, layer three. Um and for what reason he's doing this view, I'm not sure, but I think it is to flatten the data, is what I presume, and then ReLU, and then I think he's calling the fully connected 3. So I'm not very sure how this is happening right now. I need to check further. Okay. Uh, okay, this is, I was putting some numbers as to how many in test and train and all that. I have to do this. So there has to be a very simple code over here, which will basically read the directory and print out how many files are there, and so that basically helps having those numbers handy. So that's okay, that I put a to do, I'll do that later. Then optimizers, okay, yeah, so this is from the official this thing. So smaller the learning rate, better convergence, less chance to be stuck in a local minima during gradient descent. This is my own comment. So yeah, from what I understand about optimizers and how they are utilizing the learning rate, so there are better chances of convergence of the algorithm if there is a smaller learning rate, because, and I saw a couple of videos, obviously Andrew NG and others, wherein they explain that if we have a larger learning rate, then it is quite possible that your uh, gradient descent, that entire process will fail and it will get stuck in a local minima, and it will not really go to the uh, you know the actual the global minima, so to say, where it is supposed to, which will be the lowest point. And of course that Andrew Ng explains that very well with that graphic with two weights and that that 3D model which is there. So any which ways. So okay, so there are two optimizers on this link itself. There are mentioned these two optimizers which are there. One is a stochastic gradient descent, this one, and Adam. Okay, so they prefer Adam, and I think they have a comment somewhere in the book saying that this is the reason we are preferring Adam, or in this code somewhere. But over here, and then most of their official listing, they are using SGD. So I thought maybe I could use SGD, but that's okay. I am going with their code right now, and Adam is what it is. Fine. So then they've defined the train. So the model, the optimizer, the loss function, train loader, validation loader, the train loader, validation loader we've defined here. Epochs by default he's giving 20. You can pass in whatever value. Device he's by default giving CPU. So if we have a GPU available, we'll check for that and then we'll pass everything and move everything to the GPU. Now for epoch and range, so he starts off with 1 and goes to num epochs plus 1. Training loss, I think this is initial values, validation loss, initial values. Model gets trained over here, and once training is done, then rest of it is inference on or evaluation on the validation set is what I presume. That is what I could understand from the code. I need to really understand this. So for batch and train loader, so within that train loader, you'll run for one batch, and then optimizer zero grad because whatever gradients are coming from the earlier batch, we don't want to carry them and accumulate them for this particular batch. So delete all gradients from last batch. um, Inputs targets from the batch you are extracting. This targets is a dictionary of uh, metadata, so to say. Depending on the use case, I think it differs because over here targets for faster RCNN and for mask RCNN, that targets is quite a well defined dictionary, and they do that up here, if I am not wrong, in the get item or in the init class. So yeah, right. So bounding boxes, labels, masks, image ID, area, is crowd, not crowd. Is crowd is basically a class 0 and all that. So over here, I'm not sure how that structure of the targets is. I really haven't seen that. I need to do a print somewhere. So I did do a print on the shape, but besides that, I have not really got into what all is there. Okay. Then inputs to device moving the inputs to CUDA, the GPU. Targets dicts again moving it. Then model, you pass it the inputs and you are getting the output. Then the loss is getting calculated here. The loss function is defined. Um, then backward propagation of the loss through the network. Then optimizer dot step. So this again I miss now as to what it is, but yeah. So that's again a regular thing which is happening in here also and other examples also. Okay, so training loss is calculated. Training loss. I'm not sure what is happening here. So again, I need to check. So model eval. Then again, num correct, num examples. Okay. Again, this all exactly the same code that is happening up there. Besides, so lost data item is getting multiplied by inputs dot size. Okay. So validation loss, and of course all of this I really need to go through. I've not gone through this. I've just copied their code from their repo exactly like this. And now okay, so this I'm just printing as to how much GB my GPU is occupied over here, how much of it is actually the memory is occupied, and now making predictions, and that's about it. So rest of it can come in main. So first you create the training data, the validation data from the train data path, the validation data path, and test data path. uh, haven't really utilized this, like in their code also they're not utilizing this, they're just running it on a couple of images. I have also done that. I just got about 5 6 images together and just ran on that. So batch size initially I ran for 10. So they mentioned something about mini batches and all that. Officially it is one. In most of it you'll see it as batch size of one. Okay, anyway, so train data loader, and this you're calling the simplenet class object, and initializing, then optimizer, then okay, again printing, and again moving the model to device, and till here there is no utilization of the GPU, because, and of course when the training starts, then within the train method I have written this one prints a couple of times and it lets you see that GPU is being utilized, and so yeah. So they now over here they in the labels they are mentioning two classes, cat and fish. I have airplane and not plane. So there are five sample images that I'm picking up, and I have just kind of shuffled those images twice thrice within this list, uh, so that I have a small list to quickly test the code, and then it prints out saying whether it's a airplane or it's not a plane, right? So airplane or not a plane. So this is what it is. It's extremely simple code, and like they call it the simple net. So yeah, so I was running it here, and this is the log file I created. So I will not override that log file. I'll create one more. I'll call it log 4, and let's see how this goes. Mm, this is what I got in the earlier run. I'm quite surprised, but each and every image got uh, classified properly, right? So there are two airplanes, which are these, mm, and 4 and 5. And after 4 and 5, I gave it 1, and now I give it 5 again. So earlier I didn't have this, so I just have it had it till here. But let's see now if it gives me 4 and 5 as airplane, and then gives me not plane, and then again gives me airplane. That means it is performing quite well, and so this is how the memory allocation went, and here also. Uh, So this is pretty, this is very, very light in comparison to what I've been doing earlier over here with the, ResNet. This one totally doesn't run properly. So, and I've said that couple of times. There's 2 3 videos that I've been recording recently. This one gives me a lot of issues on my GPU. So any which way, so this I have to again see what I can do, whether optimize the image size or whatever. And this you see, it's just already done, right? So this is quite fast. So again, going through the earlier log, and I will go to the new log. So over here you see that training loss is 0.01 and validation loss is 0, right? And accuracy is 1. This is a 10th epoch, and if you were to look at the first epoch, there itself it is giving an accuracy of 0.99, right? So these are pretty amazing results, at least from what I've tried earlier and what I get to see now. mm, I see this is pretty decent. Okay, and over here again, okay, so let's see now, this is what we ran right now. Again 0.99, 1, it's already 1 in the second third epoch, and this is what we get, and not plane. So here we have airplane. Okay, so again, all of the images, it's classified properly, right? So it's only 4 and 5, and the last one, which is airplanes. So image 4, 5, that is what is airplanes. The rest of them are. So I don't know how it is doing this. I'm pretty impressed right now. So maybe it's. I have no clue. So I really need to look into this and probably post back later. Yeah. Thanks.